We are getting ready to start the Flash Talk presentation. My name is Arnulfo Perez, and I'm from the Ohio State University. The Flash Talks are opportunities to share essential information about a project with the STEMC community in a rapid-fire presentation driven by automatically advancing set of presentations. So the slides are going to be advancing as we speak. If it's a single PI in the project, they have about 5 minutes. And if they have a bigger partnership, they get about 7 minutes. So you're going to watch them sweat. We have 5 panelists in our, we have Carolina Ruiz, Jasmine Kafai, Yulin Zhang, Shushi Grover, and Chad Dorsey. All right.
Hello, I'm Carolina Ruiz. I'm a computer science professor at WPI in Massachusetts. Liz and Sherry are here in the audience as well. We're developing a bridge between biology and computer science that integrates the teaching of computer science and biology by bringing computational thinking into biology and biological thinking into computer science. I'll talk today about how our BioCS bridge motivates the integrated learning of science and computational thinking in high schools by using a real-world citizen science research project. I'll start by saying that at the core of our approach, we have 3 high-impact teaching practices: project-based learning, community-based learning, and involving students in research. As you know, these practices have some benefits, or multiple benefits, but also some challenges. Among them, promoting active engagement, collaboration, both inside and outside the classroom, and they can push students and teachers out of their comfort zones, which is very good. But it's also scary and requires very thoughtful implementation as well as sufficient support for teachers and students to succeed. WPI, project-based learning is really in our DNA. We have been totally committed to project-based learning at the undergraduate level for over 50 years, and we have been very successful at that. And now, with this project and other projects around campus, we are trying to find ways of sharing that expertise and transfer these to the high school framework. We're doing so in this project by using a real-world citizen science research project. In particular, we're working on a problem that is an environmental problem, that is the research area of our PI, this writer, and our co-PI, Rob Gier, namely looking at pollination decline, causes, and effects on the whole ecosystem. So what the BioCS bridge is doing is actually engaging both computer science students as well as biology students and teachers, high school teachers, in scientific practices using biological data that they collect and computational tools that they help to design and implement. And these tools that are developed with and for the students are also shared with the general public. So as we develop these tools, they become available on our website, and then the general public are also using these tools to contribute to this this research project with data, and they are able to use these tools as well as the students for doing data analysis, data visualization, simulations, and so on. And this brings a new aspect of authenticity to the project for the students to see explicit connections between biology and computer science and see that this is a problem that has impact. Okay, we are implementing this using a transdisciplinary team approach, and we are investigating the effectiveness of having horizontal integration across disciplines as well as vertical integration. So we have, as part of the design team from the very beginning, students at all levels, high school, undergraduate, and graduate students working together with high school teachers and university faculty. This has provided us with active engagement of all the stakeholders, collaboration, expertise sharing, as well as kind of a joint curriculum that we have developed jointly. And this goes back to what I was saying at the beginning of the need of really implementing this thoughtfully so that students and teachers especially have what they need to succeed. Okay, so what have we learned so far? We have learned teachers have reported strong student engagement. Students enjoy working on a real problem and really contributed to a research project. And this has deepened their learning of both computer science and biology. The transdisciplinary team process has been essential to developing this truly integrated curriculum, and it has created this balance among the different perspectives, both vertically and horizontally. One important thing, as you can imagine, is communication. Communication is key, and we have been learning to speak each other's language, not only across disciplines, but also vertically. And then that has brought new ways of communicating content to students in a more effective way, like creating cognitive artifacts. And also something special that we have done is that we have gone to conferences to present our work together. So here are students training, high school students training other teachers. And then we present together, and that gives us kind of a sense of ownership, feedback, coherence, and so on. In the short term, we'll continue doing this and assessing what we're doing. And in the long term, we want to work on creating a blueprint that will really generalize the approach that we're following to allow other universities and high school partnerships around the country and even around the world to use this idea of forming transdisciplinary team, using project-based learning, integrated curriculum, that can be applicable to other biological problems plus C, other STEM disciplines plus C, and even some non-STEM disciplines like the humanities or the arts with C. Thank you.